From this presentation, we will discuss the question asked in Assistant Professor exam conducted by BPSC on 26th May 2023. Question paper consists of 80 questions. So to make the solution for all the 80 questions, one video would not be sufficient. That's why I have divided all the solution in 4 parts. Each part will contain the 20 question. So let's start with the first question. The first question is, this first search graph uses which data structure for its implementation? So the answer is a stack. I have added a graph to explain this question. So in the graph we have 5 vertex S, A, D, B and C, and we are starting the depth first search algorithm from the S vertex. So we will go in the depth. So first we will start from the S, then we push it into the stack, and then we visit the A because it is adjacent to S, and then from A we will go in the depth. So what was happening in BFS, breadth first search? After A we will visit the B, but here we are not visiting the B, we are going in the depth. S, then A, then D, then B and then C. So the order of the DFS will be S, A, D, B and C. Now move to the next question. Next question is about NOR gate. First we will read the question, then we will see the solution. The question is, what is the minimum number of gate required to implement the Boolean function AB plus C if we have to use only two input NOR gate? So the expression is AB plus C. We can expand it as A plus C, B plus C. Now we can clearly see it is a OR AND circuit. We know that OR AND circuit is equals to NOR circuit, and A plus C and B plus C is a standard format of NOR and diagram is also added below. You can see clearly. Yeah, it is taking 3 NOR gate. NOR circuit takes 3 NOR gate. Answer of this question will be 3. Now move to the next question. The next question is, in the following index addressing mode instruction, move 5 R1 LOC, the effective address is. Yeah, so this is a base register instruction. So base register, here base register value is memory location which is mentioned in R1, and the 5 is the offset value. And like when we add the base address with offset, we will get the effective address. That would be 5 plus memory, the content of memory address mentioned in the R1. Base register addressing mode is used to implement inter-segment transfer of control. Inter-segment transfer of control means it is used when we want to switch from one memory segment to another memory segment. Yeah, so now, so the answer of this question will be D. Now we will go to the next question. Fourth question is, which protocol combines the advantage of both link state and distance vector routing protocol? So in this answer will be EIGRP. So we will go one by one. What is the RIP, OSPF, IGRP and EIGRP, and what is the protocol it is using? So RIP stands for Routing Information Protocol, and it is a distance vector protocol. OSPF stands for Open Shortest Path First, and it is a link state protocol. IGRP stands for Interior Gateway Routing Protocol, and it is also a distance vector protocol like RIP. EIGRP stands for Enhanced Interior Gateway Routing Protocol, and it is the link state routing protocol as well as vector routing protocol. It is also called hybrid routing protocol. EIGRP needs low and less bandwidth, and it supports variable length subnet mask. Now move to the next question. Now the next question is about the memory access time. So we will read the question first. If memory access takes 20 nanosecond with cache and 110 nanosecond without it, the ratio is, so it is asking for the hit ratio. So the cache access time is 10 nanosecond. Here it is given in the parenthesis, we can see. And the memory access time, the average memory access time is 20 nanosecond. And the main memory access time is 110 nanosecond. So here in the solution, you can see it is handwritten solution by me. So T average is 20 nanosecond, T1 is 10 nanosecond, and T2 is 110 nanosecond. T1 is nothing but cache memory, and T2 is nothing but main memory. So the we will use the uh, formula of memory access, average memory access time. So it would be h into T1 plus 1 minus h into T2. So T average is 20. So T1 will be 10 into h plus 1 minus h into 110. So the expression would be 10h minus 110h plus 110. So after subtracting from 20, it would be 90 equals to 100h, and the hit ratio will come as a 0.9. Yeah, so the answer will be B here. Now move to the next question. This is interesting question. So it is about C programming. So one for loop is given, and we know that in for loop three sections are there. One first section is used to initialize the variable, and the second section is used to check the condition, and third is to increment or decrement the variable. So similarly, it is using two variable I equals to 1 and j equals to 10. And for the I equals to 1 and j equals to 10, if it will check for the 1 is less than 6 equals to not, so it would be true only. So it will print the 1 and 10. Now, and it will increase the I and it will decrease the j. So the value will be 2 and 9. So in the solution we can see it is 2 and 9, and it will check for the 2 also. 2 is less than 6. Yeah, it is true. So it will print 2 9. So it will continue till the I becomes 6. So when I becomes 6, so 6 is less than 6. So here it will fail, and it will get it will get from the out of the loop. Yeah, it will get out from the loop, and it will print 110 29 38 47 56. So answer will be A. Now move to the next question. The seventh question is the total amount of memory depends upon A, the organization of memory, B, the size of the address bus of the microprocessor, C, the size of the decoding unit, and D, the structure of memory. Yeah, here the answer will be B, the size of the bus of the microprocessor. So the total amount of memory depend upon the size of the address bus. If the address bus size is 4 bit, then we can have 16 address possible. So 16 byte memory we will have. So in the picture we can see the 8088 microprocessor, 8086 microprocessor. So in the both microprocessor, the address bus size is 20 bit. So we can have max addressable memory is 1048576, and it is 1 megabyte. So similarly, we can see in the microprocessor 80286, the address bus size is 24, so 2 to the power 24, so it would be 16 MB. Yeah, so here we can see the memory address depends on the size of the address bus. So the table itself is saying that it is in the memory address is depending on the address bus size. Yeah, move to the next question. Now we have a good DBMS question. It is asking for FD, functional dependency. So to find functional dependency, LHS attributes values should be different, or if it is not different, they should have equal right side attribute value. So let's go from the first option. XY tends to Z. So XY, we will see the value of XY 14, 15, 16, 32. So all the combination are different. So yeah, so it will exist surely. Now we will check the Z tends to Y. So Z is 2, 3, 3, 2. So for 2, the value of I is 4, and for 2, the value of I is 2. So here we can see for two same value of Z, 2, there are different value of I. So this is not permissible here. Now go to the B option. YZ tends to X. YZ 42, 53, 63, 22. Yeah, all the combination is different. So it is permissible. Now We will see the y tends to z. Y 4, 5, 6, 2. Yeah, this is also true. So the option B is true. Now the C and D we can discard it. So we will not move further because B is itself correct, and only one correct option can exist in the question. So it is MCQ, not MSQ. Now move to the next question. Which one of the following in-place sorting algorithm needs the minimum number of swap? Quicksort, insertion sort, selection sort, or heap sort? So answer of this question will be selection sort. So a quicksort takes order of n square swap in the worst case. Partition is called n times in the worst case. So when we will have increasing or decreasing or same elements, all the elements are same in an array. So partition algorithm will call the n times in the worst condition. And one partition algorithm can have n number of swap at most. So for n partition algorithm, it will have order of n square swap. So quicksort will have order of n square swap. Insertion sort will have order of n square swap. Suppose we have the decreasing order array. So when we apply the insertion sort, it for the every element it will swap and it will go to the original position. So it will take the order of n square. Now selection sort. Selection sort will have order of n swap in every case. First it find the minimum element, then it swap at the end. Now the heap sort will have the order of n log n swap because if we are deleting one element from the root, so for the sorting we will delete either it is max heap or main heap. We will delete the element from the root and we will place it at the end. So for one element deletion, it can have log n swap. So at the end, it will have the order of n log n swap at most. So the answer of this question will be selection sort because it has the minimum number of swap. Now we will go to the next question. Oh, hard question. Is it? Yes or no? I think for somebody, yes, for somebody, no. Let's see the question and then solution. Yeah. So let A be a square matrix. So A is a square matrix of size n into n. Consider the following program: C equals to 100 for I equals to 1 to n, and then I equals to again I equals to 1 to n. Actually here it is not I, it is j in the second for, and so temp equals to aij plus c, aij equals to aji, and then aji equals to temp minus c. Then it is printing the element. And it is asking the option is the matrix A itself, the transpose of a matrix, adding 100 to the upper diagonal element and subtracting 100 from the diagonal element A, and none of the above. Okay, first we eliminate the C option. Here you can see in C it is 100. It looks like it is adding and subtracting, but it is not actually. Here in the here in the for loop, you can see in the second for loop you can see the temp equals to aij plus c. Now again in the third instruction, what it is doing, aj equals to temp minus c. If you put the expression in the temp value aij plus c minus c, it will cancel the c. So it is not going to increase the 100 or decrease the 100. It will cancel the c and the value remain the same. So c option is discarded here. Now we will see the option number A and B, the matrix A itself or transpose of a matrix. So we will go to the next slide to see the detailed explanation of this question. Yeah, so this is the same expression, same code I have written, and this code belongs to the transpose of the matrix, and this is the matrix A itself. So what is the difference here? First we need to analyze it. Just see the for loop, how it is going. The first for loop is going I equals to 1 to n, and then for loop is j equals to 1 to n. So this second for loop I mentioned, this is j not I. Yeah. So here we can see For the I equals to 0 and j equals to 1, suppose a index I am talking to explain this question. I equals to 0 and j equals to 1. So it will swap a 0 1 and a 1 0. Now again I equals to 1 and j equals to 0 will come. I equals to 1 and j equals to 0 will come. Then again there will swap between a10 and a01. So it will cancel the effect. It will cancel the effect and it will be like the same matrix at the end. Now come to the transpose of a matrix. The loop is going from 0 to n minus 1 and j is going to I plus 1, not 0. It is not starting from 0 or 1. It is going from I plus 1 to n. If I value is 2, then it will go from 3. If I value is 1, then it will start from 2. So here this I equals to 0, j equals to 1, and then again the same index is not getting swapped. So that's why it is calculating the transpose of matrix. So it is swapping only one time. It is swapping only one time. It is going from I equals to 0 to n and j equals to I plus 1 to n. It is swapping only one time. You can take the example, you can go through the code and you can see what is happening actually. So the our question code will be the matrix A itself, and this code I have taken from the Geeks for Geek. So this is calculating the transpose of the matrix. So the answer of this question will be the A matrix itself. Now move to the next question. So the next question is, which of the following register is used to keep track of address of the memory location where the next instruction is located? So option is memory address register, memory data register, instruction register, or program register. Yeah, so ideally it should be program counter. Oh, but if we look on the option, so we can clearly discard the three options like memory address register, memory data register, and instruction register. So yeah, one D can be the option, but not for sure. Yeah, yeah, ideally it should be program counter, but all the three options apart from program register is not actually the answer it is. So I think we can go with the program register. So program counter is a register in the computer processor which has the address of next instruction to be executed from the memory. So in the picture you can see the program counter is containing the address of 0x04. So it is the next instruction and all the three instruction has been executed 0 till 0x03. Yeah, so the answer would be program counter. Yeah, now move to the next question. Yeah, next question is about the partition algorithm, not exactly partition algorithm but about the quicksort algorithm. So you have an array of n elements. Suppose you implement quicksort by always choosing the central element of array as pivot, then the tightest upper bound for the worst case performance is. Yeah, so for the clear visuals of the solution, I have taken one example. So suppose in an array we have element like 6 4 2 1 3 5 7. So it is saying that we are choosing the central element as a pivot. So in this the central element would be 1 1. So what would be the recurrence relation it will form? So 1 will go to the first location and all the n minus n element will go to the one part. One will go to the one part and n minus one element will go to the one part. And in one iteration, the pivot partition algorithm will take order of n time. So it is making the worst case situation. Here we can clearly see this is making the worst case situation where one part is getting divided in one element and the other part is getting divided in n minus one element. So the time complexity for this question would be order of n square. The worst case time complexity would be order of n square. So I have also added one graph. So here you can see n it is getting divided in n minus 1 part 0, then n minus 2 part 0, n minus 3 part 0. So always we need to sort the n minus 1 element, then n minus 2 element, then n minus 3 element till it is becoming the one element. So for one level it is order of n time for partition algorithm, then another level it will be order of n time, then it will go to the one element. So overall it will be the order of n square. Yeah, move to the next question. Next question is from the theory of computation. So we have L1 and L2, and that is a recursive enumerable language of arrays. And then which of the following are recursive enumerable is asking. So L1 and L2 is a recursive enumerable language. So it is asking either L1 union L2 is recursive enumerable or not, L1 intersection L2 is REL or not, or both is REL. Yeah, so I have added one table. So closure property table of the languages. So it is asking for union and intersection. So we can see the row, union and intersection row. There REL is closed. In union it is closed REL, and also intersection it is closed REL. RE is REL, yeah. So it is closed in both. So the answer will be C. Now move to the next question. This question is about the page fault, number of page fault. In page replacement algorithm, it is asking number of page fault. Most asked question. So consider, and I am reading the question now. Consider the virtual page reference string, some string is given here, and on demand page virtual memory system running on a computer system that has main memory size of 3 page frame which are initially empty. So initially it doesn't have any page. Let LRU, FIFO and optimal denote the number of page fault over under the corresponding page replacement policy. Then what will be the answer? Either the number of page fault in optimal is less than LRU or less than FIFO, or B is saying that number of page fault in optimal is less than number of page fault in FIFO is less than number of page fault in LRU. So if we calculate the number of page fault from the different algorithm like FIFO, optimal and LRU, so B option will be the correct one. So I have added the clear representation of the number of page fault we are getting. So in all the three, the first three will be the page fault always because it doesn't have any initial pages. So cannot be possible. So all the initial three pages will be the miss only. So that will come under the page fault. Now in the FIFO we have 6 page fault, and in optimal we have 5 page fault, and in LRU we have 9 page fault. So it seems like LRU gives a less number of page fault than FIFO, but it doesn't really actually it is. Like it can be of most of the page references, but not for all the page references. So the option is B. Option B is true. So optimal is less than FIFO, and FIFO is less than LRU. Yeah. So we will move to the next question now. Suppose the numbers 7518360942 are inserted in that order into an initial empty binary search tree. Okay. The binary search tree uses the usual ordering of natural number. What is the in order traversal sequence of the resultant tree? Oh, so this is the most easy questions in this entire question. This is the most easy question. So we know one property of the BST, and that is in order sequence of a BST always gives the increasing order sequence. So we can directly see in the option what are the increasing order sequence. So A we can discard after 5 we are getting 1. B we can discard because after 3 we are getting 1. C 0 1 2 3 4 5 6 7 8 9, yeah, C is the answer. And D 9 8 6 4, yeah, we can discard the D2. So it is getting decrease. So yeah, C will be the answer. So for the reference I have added the one PhD also 5 3 4 10 8 12, and there in order is in the increasing sequence. So in order traversal BST always give the increasing order element. Now move to the next question. Yeah. Subnet mask of a particular network is 255.255.31.0. So one is the subnet mask, one subnet mask is given, and then tell about which pair of IP address could belong to this network. Okay, so we will go one by one option and we will see what will be the answer. So A 172.57, 172.56. So A we can discard. A we can discard easily because it is 255.255. So 2 octet is already 255. So then this could not be the this pair could not be the IP address which belong to the same address, because the one network ID, the first two octet will be 172.57 and 172.56. So this is not possible. So B 10.35, 10.35. Yeah, this pair can be one option. Now C 191 to 203, 191 to 354. No, C we can discard for in the same region. We are discarding with the A option. We can discard the C option too. So D 128.8, 128.8. Yeah. So in B and D we will see which one is the answer. So in B we can see like this is the 31, right? So from the in the third octet from the LSB, the 5 bit is 1. So here we can see in this is the 28 representation is 11100 11 and 29 is 11101. So this 5 bit is 1 in the subnet mask. So what would be the network ID? It would be 28 29. So these two are not belonging to the same network ID. So D will be the answer. Now see the binary representation of 129 and 128. So 129 representation is 1 and all 0 and then 1, and 161 is 101 0 0 0 0 and 1. So see the 5 from LSB 5 bit because 31 it is given. So see the 5 bit from LSB 10000 10000. Yeah, it is same. So this D pair IP address belong to the same network. Yeah, move to the next question. The length of broadcast line is 2 km and it has 10 to the power 7 bits per second. Bandwidth and uses CSMS CD. It is given that signal travels along the wire at 2108. It is not 2108, it is 2 into 10 to the power 8 meter per second. And then what is the minimum size of the packet? Yeah, so the answer of this question will be D. So yeah, let's see the solution. So to detect the collision, we know that in CSMS CD transmission time should be greater than 2 into propagation time. So we know that propagation time formula is like L by V. So here L is 2 km. So we can keep like 2000 and by 2 into 10 to the power 10 to the 2 into 10 to the power 8 meter per second. So it would be 10 microsecond. Okay, and suppose the frame size is x, right? So transmission time can be the 0.8 x microsecond. So when we put in the expression, so 0.8 microsecond will be greater than equal to 2 into 10. So x should be greater than equal to 25 byte. So here 50 byte is also greater than 25, 100 and 200 also. So none of the option is matching. So we can say that none of the above. Yeah. Now go to the next question. So in this question we have one recurrence relation and it is asking what kind of recurrence relation it is. So option is like Warthal algorithm, and second is Flodo algo, and third is Dijkstra, and fourth is saying that it is none of the above. So it is a Flood-Warthal algorithm. So Flood-Warthal algorithm is to find the shortest path between every pair of vertices, and this algorithm is different from other shortest path algorithm. So this algorithm uses each vertex in the graph as a pivot to check if it is provided the shortest way to travel from one point to another point. So yeah, it can work on both directed and undirected graph. And yeah, so the path found by the vertices acting as a pivot are stored for solving the next step, and it uses a dynamic programming approach. Yeah, of course. So And yeah, it solved the problem using the adjacency matrix representation of the graph. So here we can see it is finding the minimum distance between k minus 1 ij k minus 1 and I k and kj k minus 1, and it is just storing that sorted distance to later it will be later used to solve the bigger problem. Yeah. So but the option is little confusing. Here you can see the first option is Varsal algo and second is float algo. So it is the float Varsal algo, but the name is like first word and second word. But I was going through some link, so it is a Wikipedia link there in the right side. You can see and you can read. So it is written that the Flood-Warshall algorithm, also known as Flood algorithm, and the Roy-Warshall algorithm and Roy-Flood algorithm. So from my perspective, it is option B, and I don't know what will the actual answer from the VPSC side. So when it will come, the key will come, then we will be able to know what is the actual answer. But from my perspective, it is B option. Yeah. Now we will move to the next question. The number of instructions needed to add n number and store the result in memory using only one address instruction. So one address instruction is like we can use a instruction with the one operand. So it is asking how many number of instruction would be needed. Yeah. So from I have added one example here. So the expression is like x equal to a plus b plus c. So first we are loading into the accumulator, and then we are adding the B, and then we are adding the C, and then we are moving it back into the stored location. So here we can see the four number of instruction would be needed for the three number. So we can say that n plus 1 will be the number of instruction needed. So yeah, A is the actual answer for this question. Now we will move to the next question. The recognizing capabilities of NFA and DFA, the option A is may be different, B is must be different, C is must be same, and D is none. So on the basis of computational power, like recognizing capability, if we talk about the DFA and NFA both have the equal capability, equally powerful. Since we have algorithm to convert NFA to DFA, and DFA is by default NFA. So both of them have the equal computational power, the recognizing capability. Yeah, based on the configuration, we can say that DFA is different, NFA is different. Like DFA allows only one move for a single input alphabet from a state, but in NFA there can be twice more than one move for a single input alphabet. And also all DFA are NFA, but on NFA all NFA are not DFA based on the structure. So if I talk about the computational power, this NFA and DFA both have the same capability. We can perform all the operations with the DFA, which we can perform with the NFA. So both have the same capability. So the answer of this question will be the C, must be same. I hope you all liked the session. If you found it beneficial for your learning, then please like, share, and subscribe. Thank you, everyone.